Hello, I'm David Ferguson from MLC CAD Systems, and today I'm going to show you three useful topics that we covered during our advanced mill class for Mastercam. The first thing I'd like to do is just go ahead and take a look at your 3D toolpath linking parameters and what's going on in there. We'll dig into arc filter settings for roughing and finishing for your 3D toolpaths, and then we'll end with some of my personal best practices for working with stock models in Mastercam. I'm trying to add as many little tips and tricks along the way as we discuss this, so let's go ahead and get started. And I'd like to talk to you a little bit today about OptiRoughs, a toolpath we all know and love. But if you've ever written an OptiRough, you've probably seen something that looks like what you see on my screen right now. An awful lot of retracts, what I kind of jokingly refer to as a little bit of a pogo stick with your spindle. We're bouncing up and down quite a bit on this OptiRough. And this is a very simple, straightforward OptiRough. Some step downs, some step ups, pretty much standard fare for what you're asked to do with your OptiRoughs. A little bit about this part. This is an older part from Mastercam's Tech Exchange. So if you go on Mastercam's website, you could probably find this guy on there, download it, and play with it yourself. But this, again, very complex shape, using an OptiRough as I would. But that tool is simply bouncing up and down, a bit like a crazy person on a pogo stick. So we want to look to see what can we do with our linking parameters for an OptiRough to, get that to be just a little less chaotic. And that's kind of the only word I have for it. So what I'm going to do here on my screen is I'm going to go ahead and go into my parameters for that OptiRough. And specifically, I do want to look at my linking parameters page. There's lots of little good things in here to help out, not just OptiRoughs, but as we'll look into a little bit, your other 3D toolpaths, because they all, for the most part, have a very similar linking parameters page. And what this really is, this is all about my retract heights, my retract strategy, and my lead in and lead out values. And there's quite a bit going on here. So at first glance, this is a very dense page with a lot of information. I'm just going to go ahead and point out really kind of the key points where you can, get some of the extra travel out of your toolpath, maybe improve the runtime, the efficiency of that toolpath a little bit. And the very, very first thing I want to look at is my retract strategy. OptiRoughs give me three basic strategies for retracting. Again, this is uniform among most of the 3D high-speed toolpaths. So what I'm talking about here applies to hybrids and rasters and equal scallops and waterlines and all that kind of good stuff. So, it's sort of a blanket statement a little bit. So the first thing I'm looking at here is my retract type. And I've got three basic strategies I can do. And by default, this toolpath is simply doing a full vertical retract, which means every time that tool comes off a cut, which on an OptiRough is quite often, I am retracting to whatever value I have set for my clearance plane. And that's just a Z value, either an absolute or an incremental value, positive, negative, obviously, depending on, the way your part is set up. In this case, I have a standard issue, positive 2 inches, which again is causing that tool to retract to that height each and every time it has to reposition itself at the end of the cut for the next cut. And we want to do better than that. So what we're going to look at is how I like to program OptiRoughs. And I use OptiRoughs in my regular machining practice, and I use them on basically very complex positive molds, very large molds, so travel time is a concern for me. I like to keep the runtime down where I can. So this is how I set up OptiRoughs for myself. And again, may be applicable to kind of how you want to run them, but it's a good strategy overall. So the first thing I'm going to do is change my retract strategy from a full vertical retract to my preferred method, which is a minimum vertical retract. Instead of using then a clearance plane, although I will still see that value at both the very beginning and end of the operation, what I use with a minimum vertical retract or a minimum distance value is a part clearance value. So based on whatever drive or check surfaces I've selected for this toolpath, the part or the tool, the tool will reposition itself using those, drive surfaces basically as avoidance regions. I don't want to move through the part. And I can set basically a buffer there, 150 thou is the default value, and that's plenty to basically allow that tool to move around safely. However, when I generate this toolpath, sort of with the default settings, what I start to see, again, is a much lower retract height. I'm not going up to those 2 inches, and I'm staying sort of clear of the part. But I am seeing those as rapid moves. And that does worry me a little bit. If you're familiar with the phrase dog leg, you know that sometimes when a CNC mill is rapiding diagonally, it sometimes kind of decides which way it's going to go up to it, kind of on its own. And that can sometimes, present you with a bad day in the shop. But of course, that only happens on rapid moves. What I can do with all of the linking parameters for the 3D high-speed toolpaths is I can choose to output all of those transition moves simply as a feed output. And of course, when my machine is feeding, I'm not going to perform a dog leg. So if I'm doing anything other than a full vertical retract, if I'm doing a minimum vertical or a minimum distance, I'm always going to do that as a feed rate. And in all the years I've used OptiRough and kind of used these basic settings, outputting as a feed rate, I have never once nicked or run into the part while transitioning from one cut to the next. So that also allows me to give an option if I'm feeling confident, I know that's going to be safe. And again, I can set that feed rate to kind of whatever output I need as far as how quick it needs to happen. I can start thinking about bringing that part clearance a little bit closer, and that is just sort of a matter of comfort. So instead of 150 thou, I'll go ahead and bring that down to about 75 thou. Again, just trying to cut a little bit of that distance out of there. And I'll go ahead and regenerate that and just kind of see what this looks like. You can see, yep, just bringing everything, again, just that little bit closer. Now, the other thing I can look at with an OptiRough to sort of shed some time, and I'm going to go ahead and get myself sort of zoomed in here on my entry, and if we can kind of see my entry motion, this is sort of this green area here. I am using advanced display to display my entry motions as green, so hopefully that's noticeable on your screen. I have 2 basic sort of entry motions, and this is, again, the same for all the 3D toolpaths. I've got a primary lead, well, we tend to call it primary, and then I've got a secondary lead. And basically on the beginning of each cut, or each pass, I would perform whatever the secondary lead is set to, and then I do the primary, right? So secondary first, primary second on the entry to the cut. On the exit of the cut, I would do the primary, my immediate sort of move away from whatever surface I'm machining, and then I would perform the secondary, on the way out. So it's secondary, primary on the way in, primary, secondary on the way out. And basically, I have a choice to do that as any number of sort of either horizontal or vertical arcs at a sweep angle, at a ramp height, at the size of that arc. I can make that as big or as small as I need to. The question I'm usually asking myself is, do I really need that secondary lead in or lead out? And with OptiRoughs, depending, typically in this case, it's an outside strategy cut. So I'm outside the material kind of cutting into the side of it. I don't really know why I need that secondary lead at all. So I can literally just turn that all the way off, and I'm left with just a horizontal entry into my cut and a horizontal exit on the way out. Again, if I want to, I can also make that a vertical arc entry and exit. I can tighten up the size of that radius a little bit. I can shallow the sweep somewhat. I can have a slight linear motion with a distance value. So I'll go ahead and I'll just do, say, maybe a 50 thou linear motion. I'll drop the sweep angle to, say, 60 degrees. And the radius, I don't need 75 thou. That's a pretty big arc. I'll go ahead and drop that down to 25. And I'll leave the ramp angle there at 10 degrees. So just trying to tighten that up overall. And regenerating that, this is what I then see. My arc entry, or my entry, again, is just now sort of a traditional sort of shallow arc. I don't see that large secondary sweep at the beginning of the toolpath, and I don't see it at the end, right? And again, I can do that the same for other toolpaths. I'm going to go ahead and take a look at a waterline toolpath here. And you can see I've got kind of that same thing going on right there on the entry. I've got a large vertical arc in, followed by a horizontal arc, and I just want to, again, kind of tighten that up. So I'm going to go into the linking parameters for that, and I can see, okay, yeah, I've got a horizontal arc, again, kind of those same default values the OptiRough had, as my primary, and a vertical arc as my secondary. Now, for a finishing toolpath, that secondary arc may not be a bad thing. I just really don't need it to be that big. So I'm just going to try to tighten all of this up just a little bit. So Again, I'll leave the distance at 0 this time. I don't need my linear entry. But I'll drop the sweep angle again. I'm going to go to 60 degrees. I'll drop the arc radius to about 25 thou. And that's for my horizontal portion. So that's the direct contact to the cut. And then, of course, the move directly out of the cut. And then for my secondary lead, I'll leave that at vertical. But again, I'll just kind of tighten that up a little bit. Just drop that value down to about 25 thou. And then hopefully what I see when that regenerates, we might have to wait a second for this one. It's got a lot of passes. I just see that entry and exit just be that little bit smaller. And anytime I can find a chance to sort of shorten some of those travel times out of a part, entry and exits are a good place. Retract heights are a good way to do it. Hopefully I'm just increasing overall the efficiency of how that toolpath is going to work. And again, if I am concerned about dog legs or moving that tool in an awkward position, I can always do those sort of minimum vertical or minimum distance retracts as a feed rate. And I sort of remove that chance of a dog leg happening unexpectedly. Okay, so just a couple of tips on how to just maybe tighten up and look at that linking parameters page for 3D high-speed toolpaths, and hopefully maybe a slightly different way than you are now. I'm going to talk to you a little bit about the arc filter and how to apply it to both roughing and finishing toolpaths from that 3D high-speed toolpath gallery we so love to use. So this is a part we were talking about earlier. On my screen is just a kind of a complex shape, and I've got a couple of toolpaths to rough this out and some toolpaths to finish it. And specifically, I'm going to be looking at applying my arc filter to my roughing toolpath, which is, of course, a 3D high-speed dynamic OptiRough, one of our favorite toolpaths, and a waterline toolpath for my finish pass. Again, one of our favorite toolpaths. And how can I use the arc filter for the roughing toolpath? One, to make the roughing toolpath a lot more palatable for my machine, reduce the code size, and we'll look at that here in a sec is what I'm talking about. And then how can I use the arc filter, not necessarily to make the toolpath smaller, although that will be an offshoot or a side benefit for a finishing toolpath, but just how to make the toolpath flow better. And we'll go ahead and we'll take a look at that in a moment. The first thing I really need to do or know how to do in the software is understand how to view my toolpaths in a way that I'm getting the maximum amount of information from the software without necessarily having to look at the NC file or without having to maybe run it and verify. I just want more information. So when I'm looking at the toolpath right now, and this is my op number 1, again, my OptiRough, I'm viewing this in your traditional sort of Mastercam color palette for toolpaths, which is basically 2 colors. I've got blue for feed motion, and you can see I'm moving around the part, repositioning using all feed rates, and yellow for rapid motion. And of course, I can see that at the very beginning and end of the operation where I've got a couple of just of vertical moves to a clearance height and then back to it. Everything else is generally happening at a feed rate. I don't really get necessarily a lot of information beyond that. So one of my favorite buttons in Mastercam is what is called the Advanced Toolpath Display button. And if you're not using this button, I highly recommend you do so. If I go ahead and click sort of on the pull down for Advanced Display, I can look at all the different things, types of toolpath motion I can see, and basically dictate each of one of those as a different color. And the one I'm very interested in is the last one, what are called endpoints. Because when I view this toolpath with endpoints displayed, I may be in for a bit of a shock. Now, traditionally to view endpoints, I could also do that in backplot. I could backplot a toolpath and say I'm running in either incremental or trace mode. I do have the ability to turn those endpoints on in backplot, and there they are. Wow, that's a lot of them. So we're going to have to do something about that. But I have to launch backplot to see that, and that's a little annoying, because if all I'm trying to see are endpoints, it'd be nice if I could just see those on my screen. So I'm going to first turn on the ability of my Advanced Toolpath Display to display those endpoints, just by making sure that box is checked. Okay, I'm still not seeing them because obviously I need to turn that button on. So I'm going to go ahead and click my Advanced Toolpath Display, and I'm seeing those endpoints now displayed. So here is Advanced Toolpath Display without the endpoints displayed. I can see, hey, there's my transition color, is that nice rusty color. Entries are green, exits are red. I still have my traditional blue and yellow, so for feed and for rapid, but I get to see different types of feed as different colors, and so I just get a little more info out of that. Now, if I'm maybe a little uncomfortable with my color choice there for my endpoints, geez, that's pretty bright. On my View tab, up top on my ribbon, I do have an advanced toolpath display button, and that is just an on-off button for that function. But if I click down and to the right of that button, I do have my display options. So from that, and this traditionally would be located in your configuration, but now we can access it in real time without having to launch our config. I'm going to find over here on the left, hey, there are my endpoints. I can make them larger, to the point of just obliterating your part visually. And of course, I can also change their colors. And that yellow is maybe a little hard on the eyes, so maybe I go with something a little nicer, something with a little more pop. White is always a good color for those. They do have a lot of contrast, but basically that's what you're looking for, is just something with a lot of contrast, so it's very obvious what you're looking at. And you can adjust that sort of in real time. When you do make those changes, it does ask you if you want to save that to your config. If you don't, you can just say no, and it's just sort of a one-time change. So whether you want that to be permanent or not is ultimately up to you. But boy howdy, there are a lot of node points. As you may or may not know, with tricordial or dynamic toolpaths in Mastercam, they tend to be linearized by default. The arc filter is never turned on as a default setting for reasons, I'm sure, but it's not, so we just have to deal with it. And you can see you've got just these long sort of string of pearl effects where the toolpath is basically checking its position again and again and again, even on what amounts to be large, mostly linear, nearly straight line moves. And that's simply going to generate a lot of code. It's going to be a lot of code for the machine to get through as quick as I tend to run these toolpaths. So my machine might struggle to keep up with this. There's all kinds of reasons why I want to get rid of that linearization. Mostly because it just makes the toolpath just unnecessarily big. So for OptiRough, a real good basic sort of structure, and I'm just going to show you what I run my filter at when I run OptiRough. So I use OptiRoughs pretty much every time I machine something. Large positive molds is what I make. So this is stuff I do just as a common practice. Under my arc filter tolerance page, I'm going to check a couple of boxes here. And the first one I'm going to check, obviously, is just to turn the filter on. Assuming my machine is okay with it, I'm going to generate arcs in all three planes using a G17, G18, or G19. But just the G17 alone can save you quite a lot of linearization, because we're basically trying to get more arc output with this, or at least, at the very least, reduce some of that linearization. For OptiRoughs, I also have the option to output a 3D arc entry motion. That's helixes or ramps or medial entries can generate a lot of code sort of on their own. So it just lets me kind of, again, use an arc output, a 3D arc output, preferably, for any sort of entry motion. And then basically I'm just going to go ahead and play with my slider here. Now I've got a total cut tolerance of 1,000 here. Or I should say toolpath tolerance of 1,000. My cut tolerance right now is a number I can't even pronounce. And basically sort of the way you can kind of work with this, or an easy way to think about the basic arc filter, is that to the left, this slider here, more towards cut tolerance, that tends to be more linearization. Towards the right, towards what they call line arc tolerance, that tends to be more arc output. And you're basically looking for some sort of balance between those two. And I found over the years that my preferred sort of setting for that slider tends to be somewhere from 20 to 30% for cut tolerance. So I'll go ahead and I'll put in 30% cut tolerance, which leaves me 70% for arc creation. Again, 2080 is also sort of my favorite. So somewhere between those two ranges gets me, again, sort of the results I'm looking for. So just noting the size of the toolpath right now, the size of at least the raw NCI data is about 1150K. So it's not a small piece of code. And applying this filter, this is what's going to happen. So I'm just going to green check and generate that filter and allow that toolpath to regenerate here. And since my advanced toolpath display is still on with those arc outputs, with those endpoints there, I can see dramatic reduction in the number of those points. My toolpath is reduced by, just a crazy amount. It's now about 171K in raw NCI data, so it's a much smaller piece. It's still holding a tight tolerance. It'll still be well within whatever I'm trying to hit. It's just a lot less code for that machine to chew through. Really, any of the toolpaths in Mastercam that are labeled as tricordial or dynamic, so dynamic mill, even dynamic peel mill, even dynamic face sometimes, but especially OptiRough, greatly benefits from my ability to reduce that file size, reduce the number of endpoints or node points I'm generating, get some G2 and G3 output with that, so the tool is flowing a little bit more. Older machines have maybe a little more time to think about what the next move is. So it's just generally an overall improvement of what that toolpath is capable of doing with the amount of code provided. Same toolpath, a lot less code, and just a nicer, more flowing operation. Now, looking at this in terms of a finished toolpath, which is a slightly different mindset, I'm going to go ahead and highlight my high-speed water line here. Okay, and this water line is not using any arc filtering whatsoever. And what I'm going to do is I'm just going to kind of look at one area on this part with this water line. And I can see that, sort of like buying a car at night and in the rain, hey, it looks pretty good, from 30 feet. As I get closer, it's not maybe going to look so friendly. I don't really feel like I'm following that surface very well in some of the tighter, smaller areas. As we can see with those endpoints displayed, I am, that doesn't look that great. It's not bad. I mean, it probably would be okay, but I know I can do a lot better with that. So what I'm going to do for this is I'm going to make a copy of this water line, just a direct copy, right? Not going to change any other values, with the exception of I'm going to apply the filter settings that I like to use when I'm making molds, and I'm using a water line. Again, one of my favorite toolpaths. So over here on the left-hand side, I'm just going to go ahead and just copy this guy. And the reason I'm copying it rather than just changing the one I have is just to be able to A-B between the two. So I'm just going to do a simple copy after, and that's just a right-click, drag, and hold. That's how I like to copy stuff. There's my new water line, again, exactly like the old one, except this one's going to get the filter applied to it. So I'll go ahead and go in to the parameters for that. I'll go down to my arc filter. And again, I'm not using anything here. Okay. So I'm going to do this in much the same way, with the exception of that for a finished toolpath, I might bring in some smoothing settings to help sort of even out some of those passes a little bit. So this isn't always necessarily going to make my toolpath smaller. It typically does. But sometimes applying a heavy smoothing element can sometimes sort of blow it up a little bit. So you do got to be aware of that if file size is a concern. But generally speaking, it will make it smaller overall. And right now, this water line's at about 13K or so in NCI data. So it's, again, a pretty big toolpath. So I'll turn on my filter a lot like I do for an OptiRough. If the toolpath allows me to do so, I will always output 3D arc entry motion. They don't all give you that option, but when it's there, use it. And I'm also going to turn on my smoothing settings. Now, this gives me sort of the ability to distribute my overall total tolerance for that toolpath, which again is at 1,000, and that doesn't change, between sort of linearization, or what cut tolerance, how often do I need the toolpath to check itself, and even if we reduce that number greatly, it's still a very accurate toolpath, and then arc creation or line arc tolerance, and then finally some smoothing. So this may seem like a confusing kind of thing going on here, but basically you're looking to just put your emphasis where you want it. Obviously, the more value I have in cut tolerance, the more linearized a toolpath tends to be. The more value I have in my line arc tolerance, generally speaking, the less linearized, or easy way to think about it is the more arcs you tend to get, being the opposite of linearization. And then the more value I put in smoothing, potentially the smoother that toolpath's going to look. For me, what I've found in programming these guys is I like to pull a lot of value out of cut tolerance and then sort of equally distribute between arc creation and smoothing. So what I'm going to do here is I'm going to drop, say, 20% in my cut tolerance. And then I basically got 60% sort of left, or sorry, I should say 80% left over. So I'll go ahead and put this at 40% there, which leaves me 40% for smoothing. Okay. And that's all I'm doing. So 20, 40, 40 is kind of what I refer to that as, right? So again, most of my emphasis on arcs and smoothness, okay? So I'll go ahead and green check and regenerate that toolpath. And basically what we'll do is we'll just do a quick A-B between them. So this might take a second, waiting for my water line, but okay, so this was my first one, right? We remember what this looked like, right? That is passable. It's okay. I don't hate it. Well, I do hate it. It's not very good because it's very bumpy. It doesn't follow things very well. It's a lot of node points. This is my new water line with that filter applied. You can clearly see the difference when I apply that arc output and that smoothing. Where I was turning a lot of these small areas with small linear motion, again, that's A. That's sort of my my unaltered one, and then the filter applied, just night and day. Very obvious between these two which one I would be a lot happier running. It is a smoother run all over the part. Now, I will still see some linearization in some of the smaller areas, and that's perfectly fine. That's where I may want that to, for accuracy. Sometimes, and it depends obviously on the shape of the part. Arcs don't work everywhere, so sometimes you do need some, and that's perfectly fine. But simply applying that filter from 1 to 2, again, that's 1, that's no filter applied. Here's 2 with the filter applied. It's a visual step up in both just sort of the evenness of that pattern collapsing across that surface. In this case, actually, I did get a pretty good reduction in the size of that particular file. So kind of between those two, which one would you want to try to run? You can see how kind of uneven and just sort of messy that toolpath is. How much sort of just nicer and, calmer that toolpath is. So applying the arc filter to both my rough and my finished toolpaths for complex 3D shapes, especially all the 3D high-speed toolpaths, that's definitely something that I'm doing every time I write one of these. It's not something I want to skip or miss or forget about, because the benefits, not only in the reduction of the file size, but just in the overall quality of what's going to come out the other end of that machine, is just, as I said, just a legit big step up when you don't use it. So just going to show you some of my personal best practices when using stock models in Mastercam 2023. And stock models are something that we're tending to use a little bit more these days, mostly because of their increased functionality, but also because they're just very convenient to use if I follow a couple simple basic principles or best practices. So I've got a part on my screen here, and I've actually got this designed and set up to work through multiple setups. I've got a couple of view sheets. This is my setup 1, basically the part suspended in a stock boundary, just a bounding box. And that is sort of my basic stock definition to get started, or at least the dimensions of the stock I'm going to be using. On my second view sheet, I've got the part flipped over and held in some soft jaws, and of course a new plane created for that. And what I'd really like to do, and of course one of the big benefits of using stock models, is that I can transfer what I've done on one setup to a second setup without really having to create a lot of extra stuff. I can keep sort of everything centralized around a single part. There's a direct transfer again from the material I've removed from, say, an op1 to an op2, and it takes a lot of that guesswork out of what that second setup is going to look like out on your machine. So getting back to my first setup, and again, I'm just using view sheets down at the bottom. I've captured the plane that I'm using. I've captured the levels that I'm using. So switching back to my first setup, I want to go ahead and generate that first stock model. Now, one of the things that you're going to run into, or one of the things you definitely need to take into consideration when using stock models in Mastercam, is the fact that all of my stock models, and if I have 2, 3, 4, 5, 6, however many you're going to have, they all need to use the same plane. If my stock models are switching planes between each model, they don't line up together. So one of the first best practices is to make sure that you are using just the same plane for all your stock models. And an easy way to keep track of that, and this is just a great tip, whatever plane I'm using for that very first stock model, in this case my setup 1 plane right there, I'm just going to use that for all my stock models. But to avoid any confusion as to which plane I end up using, I'm just going to make a duplicate of that initial plane and use it just for those stock models. So in my plane manager, I'll just right click, go ahead and duplicate that plane, and I'll go ahead and give that a better name. I'll just literally call that stock models. And now there is, and I'll try to spell it right, there's literally no confusion to me either today, tomorrow, or whenever I'm working on this part as to which plane I'm supposed to be using for my stock models. And it doesn't matter whether I assign a work offset to it or anything like that. This plane only exists to be used for stock models. It is identical in every way, shape, and form to my sort of first initial plane that I'm programming with, and just all my stock models are based from that. So I'm going to pop over to my Toolpaths manager, and I've got my insert arrow there, and I'm just going to use stock models exclusively with this part. I'm not using a traditional stock definition here. I don't have to. Stock models can sort of fill that gap, so to speak. So there we go. I've got my insert arrow ready. I'm just going to put my first stock model right there. I'm on the correct plane. So I'll pop up to my Toolpath manager up top. I'll find my control for stock models, and I'll go ahead and give that a left click. Now, the first rule, and this is a rule for stock models, not a best practice, but an actual rule, I do have to name that stock model something. And in Mastercam 2023, they're nice enough to simply put the number 1 in there in case you forget to give it a name. If there is nothing in that name field, the stock model will simply fail to generate. So I'm going to go ahead and call this initial stock. Oops. And then for myself, and again, this is a best practice, I usually like to give something in that name that helps me indicate or locate sequence for that model. So in this case, I'll just use the letter A. And my second stock model, whatever I call it, will simply have the letter B at the end of it. And that way, when I see them all together, A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, I kind of know automatically which ones come which, or which ones come where, I should say. Now, one of the best practices I can offer you with stock models is stock models are toolpaths. They do appear as toolpaths on your screen, and therefore they can sometimes be a little intrusive or a little in the way. And of course, as we all know, if you can't see something in Mastercam, it makes it very hard to select it. So I like to know sort of that I'm looking at a stock model. And if you use enough stock models along the sequence of your programming, eventually those stock models are going to start to look a lot like your part. So what I want to avoid are having stock models that are similar or the same color, really, as something else on my screen. So I tend to think in very bright, almost offensive colors. So I'll just go ahead and make this stock model a very bright blue so that when it's on my screen, I know exactly what I'm looking at. Now, here for the stock plane, this is where I'm going to make that change. This plane would work. It is identical to the one labeled stock models, but, again, to stay sort of with my idea, I'm just going to go ahead and call that my stock model plane there. That's the one I'm going to use. And then I'm just going to go ahead and define this very simply. Since I haven't defined stock, I can't use my stock setup button to import my defined material. I'm just going to go ahead and use a select corner function here and just kind of zoom in and use that bounding box to go ahead and define the X, Y, and Z dimensions of that model. And for this first model, there are no toolpaths being applied to it. So I'll check my source operations, make sure I don't have anything selected in here. This is literally just my brick. And when I generate it, there is, of course, that brick of material that I have. And, of course, it is controlled like a toolpath, so I can toggle that on and off as I want to. Now, I've already written an OptiRough for this side of the part here. And so what I'm going to go ahead and do is just move my bump arrow down and get ready to sort of do my second setup, right? So I'm going to change my view sheets. I'm going to turn that toolpath off, of course. I'm going to change my view sheets over to my second setup. And here is that second setup, that part having been machined, flipped over and held at a secondary setup, just a vise with some soft jaws. And to program this side, I really, really do want to know kind of how much material I left behind. So I'm going to generate a second stock model. And of course, the part has stayed in the same place. My planes have changed. I'm obviously inverted from where I was before, so I can work on the reverse side of the part. And I just need to generate a model for that side. So I'm going to, again, make sure my insert arrow is in the correct place. I am not concerned where my planes are set right now. They would be set on that second setup. And if I allowed the stock model to generate with that plane, the stock model would not align to the previous one. Because, again, they all have to use the same plane. And it's super critical for that. So I'm going to go ahead and fire off up top another stock model. I'm going to go ahead and call this setup 2. Or setup 1 roughed, or whatever you want to call it. Setup 2, I'm just going to call that B. I do sometimes like to use different colors for different stock models just to see some variation. But again, it'll be a very bright, almost hard to look at color, so I know it's on my screen. And although I have the initial stock shape here initially defined, and that just carries over from the last one, I can also, as I get further down the road, want to apply just the previous model. So the initial stock shape for this model would just be whatever the last stock model sort of ended as. And that way you can sort of link and string all your stock models together. So if you go back and update an earlier toolpath, it does filter down to all the remaining models. So I'll go ahead and turn on that. I'll use initial stock A. This is B. Again, another reason why those letters help me with sequence. So that's my initial starting shape. Before I forget, of course, that I just about did, I do got to change that stock plane because, of course, it is going to use whatever tool plane I happen to be using. So I'm going to go back and just say, hey, I'm still using, for all my stock models, the plane I've labeled for stock models. That way everything lines up and there's no confusion. Your stock model doesn't end up half machined or standing on its side or off in space at times. I'll then go to my source operations and I'll go ahead and select whatever toolpaths I want to apply, again, to that initial stock shape. And then I have to look at my path tolerance value here. With path tolerance, that's basically the resolution of the model. And stock models are stereolithographic models, so the looser that tolerance, sort of the rougher that model can look. Depending on the complexity of your part and your machine surfaces, you may have to crank that down significantly. Usually I tend to drop mine down to about 2 or 3 thou, and that makes the model look pretty reasonable. So again, just tightening up sort of the overall resolution of the stock model. So there's my path tolerance, selected my toolpath. I'll go ahead and green check, and I should generate a pretty reasonable looking model. And there we can see, obviously, on the first op, I left myself a bit of a top hat to deal with. But the models do align. I have a great representation here to start my second operation to really just kind of see what I'm working with, And of course, I can use that in Verify. I can use that in my machine simulation. It's just an easy way, generally, to sort of bounce between multiple setups and make sure that the stock is consistently in the same place with the correct toolpaths applied without, again, really any confusion or guesswork involved. So again, just to reiterate kind of my best practices for stock models, use a dedicated plane for those models, just usually a copy of whatever your first initial plane is going to be, whatever that may be. Use very bright colors for those stock models. So again, when they're on your screen, you know exactly what you're looking at. There's no question that that's my stock model. It's purple and blue. And then finally, of course, take a look at that stock model tolerance, what they call path tolerance. If the stock model comes out looking a little rough, a little bumpy, in some extreme cases, your part is sticking through complex shapes, you may need to lower and tighten up that number to just make that model conform to that complex machined surface just that little better. So just some basic tips to help you kind of get your stock models just a little bit more in line with the rest of your programming. Thank you.